So hello everyone, welcome to my channel class. So today we will be discussing about integral calculus. Topic is plane area by integration. So in this topic we are going to look at finding the area between two curves. So there are actually two cases that we are going to be looking at. So this is the first one. So we have y is equal to f of x and y is equal to g of x. So if we're dealing with a certain problems, we have to graph it first. So kapag ganito yung naging itsura niya, we will use the formula a is equal to the integral of upper function minus the lower function. Limits is from a to b. So ako, pag nagsosolve, so I used to draw a vertical strip to know what's the upper and lower function. So, para mas madali rin siyang i-substitute dun sa formula, and then I put dx there para ma-ensure na lahat ng equation na isa-substitute ko is in terms of x. So, kapag ganito naman yung itsura ng graph natin, we have x is equal to f of y and x equal to g of y. So, our formula will be the integral of the right function minus the left function. Limits is from c to d. So, same process with the graph kanina. So, instead of vertical strip, so I will draw a horizontal strip to see the function at the right and the left, and then I put dy to remind me that all equations must be in terms of y. Now, let's have some examples. Determine the area of the region enclosed by y is equal to x squared and y is equal to square root of x. So we have to graph it first. So y is equal to x squared. So as you can see, it is a parabola that opens upward. And then y is equal to square root of x is also equal to y squared is equal to x, and that is a parabola that opens to the right. So we have to look for this area and of course the intersection for the limits. So how to identify this point? So we just only have to equate both y. So x squared is equal to square root of x. Then, squaring both sides, we have x raised to 4 equal to x. X cubed is equal to 1. Then, x is, of course, equal to 1. And then, solving for y is equal to x squared. So, y is equal to 1 squared or 1. So, the point of intersection of the two curves, x, y, is equal to 0.11. Now we can draw the vertical strip dx. So all equation must be in terms of x. So our upper function is y is equal to square root of x. Our lower function is y is equal to x squared. So from our formula, the area is equal to the integral of the upper square root of x minus the lower function is x squared. So dx, and limits is 0 to 1 since the x is equal to 1. So let's just simplify. So by power rule, we have x raised to 3 halves times 2/3 minus x cubed over 3. Limits is from 0 to 1. Then substitute the upper and lower limits. That's 0. So answer is 1/3 square units. Now what if you would like to try the horizontal strip? So we put a horizontal strip here and then we write dy, So all equation must be in terms of y. So this is x equal to square root of y, and this will become x is equal to y squared. So from the second equation or second formula earlier, so we have the right function. So square root of y minus the left function, which is y squared. So that is dy. So as you can see, the limits is also from 0 to 1, since the point of intersection is 1, 1. So just power rule, y raised to 3 halves 2/3 minus y cubed over 3, 0 to 1, and it's exactly the same as the equation earlier. So the answer would be 1/3 square units. So it's just the same. So our next example, determine the area of the region enclosed by y is equal to x e raised to negative x squared, y is equal to x plus 1, x is equal to 2, and the y-axis. So in this problem, of course, we have to visualize first the bounded region. Let's graph y is equal to x e raised to negative x squared. So if x equal to 0, y is of course 0. Then if x is equal to 1, so y is equal to e raised to negative 1, or 0.3679. Now if we try to graph that, the origin in 0.3679 is somewhere here. Then if x is equal to 2, then y is equal to 2e raised to negative 2 squared, or 2e raised to negative 4, that is 0.0366, and so on and so forth. Then on our graph, so it must be somewhere here. Then let's just connect the points. Okay, then y is equal to x plus 1. So if x is equal to 0, so y is equal to 1. So it lies on the y-axis. Then if x is equal to 1 or 2, I mean y is equal to 2 plus 1 is 3. So it must be somewhere up there.
What? Huh? Chocolate. Huh? Dali.
Ito na naligo eh.
Kaya nga eh, para pagka ano, may timpla na.
Then for the vertical line, x equal to 2, and the point of intersection is, since we have solved earlier, that is 2 and 3. So this is the line y is equal to x plus 1. This is the vertical line x equal to 2, and this is the curve y is equal to x e raised to negative x squared. Now we can find this area bounded by these curves and line. We can draw the vertical strip. So that is dx. Then all equation that we must use must be in terms of x. So using the formula, area is equal to the integral of upper function x plus 1 minus lower function x e raised to negative x squared dx. So the limits must be x, and since it is bounded by the y-axis and x is equal to 2, so the limit would be x is equal to 0 and x equal to 2. Then let's integrate x plus 1, so that is x squared over 2 plus x minus, since we have negative x squared there and we don't have 2, so we put 1/2 e raised to negative x squared. Limit is 0 to 2. Substitute the limits. We have 2 squared over 2, then 0 squared over 2, minus 1 half. So our answer will be 3.5092, and of course don't forget the square unit since we are dealing with the area. So that is the answer for the boundary region of these curves. Now, let me share to you some points to remember when dealing with problems about plane area by integration. So, first one, try to visualize the area bounded by the given graphs. So, kung straight line ba yun, or parabola, or curves, or anything, so you have to visualize the area bounded by those curves. So, kailangan meron tayong knowledge about analytic geometry, kung paano mag-graphs. Okay, so if you can do it mentally, so syempre, we have to solve and plot the points para mas makita natin kung ano ba yung hinahanap nating area. And then, second is identify the intersection of the curves for the limits. So, kanina, we have equate y is equal to y to solve for x. Then, after that, we solve for dy para dun sa intersection nila. So, that is very important para dun sa limits na gagamitin natin dun sa mga formula. Then, analyze the given equations. So, is it easier to solve it in all x or in all y? So, in our first example, so y is equal to x squared and y is equal to square root of x. So, all given are in terms of x na. So, mas madali pag ganyan is naka-dx. So, we apply the y upper minus y lower. And then, all equation must be in terms of x. But, we have also tried to solve it using the horizontal strip since madali lang din naman i-convert yung y is equal to x squared tsaka y is equal to square root of x in terms of y. So, yung equation natin naging x is equal to square root of y tsaka x is equal to y squared. So, on the second example kasi, we have y is equal to x e raised to negative x squared. So, if we will try to use a horizontal strip here, so mahirap i-represent yung x natin in terms of y, right? So, kapag ganun, we will just use the vertical strip. Then, draw a vertical or a horizontal strip so you won't be confused of what curves are in the upper or in the lower, or in the right or in the left, and then use the formula area is equal to the integration of y upper minus y lower, or area is equal to the integration of x right minus x left. And then after that, you proceed with integration and applying the limits. So about the limits, wag lang kayong magkakamali kapag naka-dx tayo. You have to look at the points of x, and kapag dy, so lahat naman ng y coordinates natin. Okay? So that's it. And of course, practice lang. Practice and practice. So that's it for today. If you have some questions, just comment below. Thank you for watching.